So here is a video on how we determine an equation of the linear function. Now the steps go as follows. We need to follow a couple of steps actually in order to do that. And I'm going to write them down as we go. So the first thing that we need to look at before we determine our equation is we need to remember our form of the linear function. We know that the form of the linear function is just y equals to mx plus c. Right? Now we need to get the equation in this form. And which values are we going to be looking at mainly? Which values do we need to have? We need to have the gradient, and we also need to have the y-intercept. Now, what do we do first, right? What do we see on the graph that we can actually just immediately input? The first thing that we can see in this case is going to be the y-intercept, right? Which is going to be -4. But here's the one problem that I will have over here. For this video, I'm going to actually just kindly remove this y-intercept. And the reason why I'm removing this is because, actually, I'm going to be honest with you, I just made that value up. It may be a different value, but for now, what we are going to do, we need to determine that y-intercept at some point. So this is how we are going to do it. The first step is we need to determine the gradient. Now I'm going to write that down over here. So we have step 1, right? Step 1 is going to be, we're going to say that this is going to be calculate, I'm going to say calc as short, the gradient. So we need to calculate the gradient first. And how do we do that? If you can remember the gradient formula, we have the following. The gradient formula is just going to be equal to y2 minus y1 all over x2 minus x1. Now, what can we do in order to actually get the gradient? What do we have on this function that we can actually do that? We have two coordinate sets over here. We have -1 and -1 and -5, and we also have the coordinate set with 6 and 7, which both lie on the same graph. So therefore we can use those 2 points to actually find the gradient. So we're going to have -1 and -5. So let's write that down over here. So we have -1 and we have -5. And then our other coordinate set is going to be 6 and 7. If I can remember correctly, right? Yes, 6 and 7. Okay, now we need to name those sets. If you can remember from, I recommend looking at the gradient video that I made, the video on gradient, in order to actually, this is not step, we spoke about sets. We name these coordinates based on sets. So let's call this set 1, and set 2 is going to be this coordinate. Once again, I told you, it doesn't matter which set you have, you'll still get the same gradient answer. Okay, so this x and y coordinates will be represented as from set 1, x1 and y1. And then this will be x2 and this will be y2. Now, what we can do from this point over here is we can just plug in the values. So we have m is just going to be equal to y2, which is equal to 7, minus y1, which is -5. And remember, when we're plugging in a negative number, then we're going to use a bracket around it. And this is all over x2, which is just equal to 6, minus, and then x1, which is equal to -1, with a bracket around it. Now, we can just keep simplifying it further, and we get the following over here. We have 7 minus -5, which is just going to be 7 plus 5. So I'm just going to write that down over here, because the negatives will multiply with each other to give us a positive. And then 6 minus -1, which is just going to be 6 plus 1. Now we can simplify over here. We say 7 plus 5 is just going to be equal to 12. And then 6 plus 1 is just going to be equal to 7. And that's as far as we can simplify, because 7 is a prime number. Now, this is actually just going to be our gradient in this case. So m is just going to be equal to 12 over 7. So there's our first part of the equation. So we can write that down over here. So therefore, we have y is going to be equal to 12 over 7 x, sorry about that, 12 over 7x plus c. Remember, we still need to find our y-intercept in this case. Now, how do we find our y-intercept? And this is where the second step comes in. So step 2, and it goes as follows. So step 2, in order to find our c value, we need to actually plug in, so we can see we have two coordinate sets, and we can plug in either this one, this coordinate set, or you can plug in the other coordinate set. Now, obviously, I'm not going to plug in both of them in this video. I expect you, okay, so I'll do the one, and then you can do the other one as homework. And then you can see if you get the same C value. But for now, what I'm going to be doing over here is I'm going to be using the easiest one, which is just going to be 6 and 7, because both of them are positive numbers, and it's easier to work like that. So we have 6 and 7. So let's plug those in, because we can clearly see over here that 6 is represented as the x value, and 7 is represented as the y value. And because we have our x and y values, then we can actually just plug that into the equation. I know you're probably thinking, but Dylan, what about our sets that we made? In this case, it doesn't matter. Remember, we only look at sets whenever we're dealing with the gradient. Now, let's move on over here. We have our x and y value, which is our x value being... okay, so we're going to consider this equation over here. Remember, y equals to 12 over 7x plus c. So we're just going to sub in for the y and the x. Our y value was 7 from the coordinates. So I'm just going to put over here sub or plot a coordinate on, I'm just going to say on the okay, not ln, but linear function. So that is what we are going to be doing. Sub, or we're going to plot a coordinate on the which was on the linear function. So this is what it's going to look like, right? So we had y is equal to, this is how you will state it, by the way. Remember, you need to show what you've done. So y is equal to 12 over 7 x plus c, and then in brackets next to it, I would recommend saying sub, this is our magic word, sub, and then the coordinate that you're going to be substituting in. So it's going to be 6 and 7. Then you can close the brackets. So we're basically telling the teacher over here that we are going to substitute the coordinates 6 and 7, where we have 6 being the x value, and then 7 being the y value, which is still represented by the coordinates. So we substitute the 7 into y of this equation, which is going to be over here, is equal to 12 over 7, that is a z, sorry, multiplied by the x value, which is 6, plus c. Now, what you can see over here is that we now have one variable that we can deal with, and we need to solve for c. So what we are going to do, we're going to take this, or we're going to simplify that one, and this is just going to look like 7 is equal to 12 multiplied by 6 is just going to be equal to 72. So it's going to be 72 over 7 plus c, which is just going to be c is equal to, you just need to do this, you need to take the 72 over here, and you need to minus both sides by 72 over 7, and then you'll get a final answer of, I think, let me just write this step out quickly. I'm just going to say, okay, so we have c on its own now, and we minus both sides by 72 over 7. So it's going to look like this, 7 minus 72 over 7. And then if we put it in the calculator, because I don't really expect you to do that calculation. I mean, if you want to, you can do that calculation. But we're going to get an answer of, it will be minus, okay, so we got as minus 23 over 7. Which is approximately negative 3, to, let's say, let's say 2 decimal places, 29, 3,29. So that it's approximately equal to negative 3,29. Okay, can we see if that is true over here on the graph? Now that was a long step over there. Okay, so let's see this one over here. This coordinate will therefore be, because remember we found our y-intercept, this will be 0, where x value is equal to 0, and this will be negative 23 over 7. And remember we said it was approximately negative 3,29. We can clearly see that this point is between 0 and negative 5. So therefore we did something right in that case. So let's just run through the steps again. This is the only example I will be doing actually, because this is probably a very nice example to go over. And please, if you are lost, just go through the video again, see where you are lost. But if you are still lost, please let me know in the comment section down below, and just let me know if there's anything that was not understandable. But right now, our first step was that we needed to calculate the gradient, right? And we used the gradient formula. We used our sets our sets of coordinates to actually plot it into the formula. Then we got 12 over 7 as our gradient, which we actually wrote down 12 over 7, which was going to be y is equal to 12 over 7 x plus c. And then we had step 2, which was we had to sub or plot the coordinates that were on the linear function into the linear function. So I took 6 and 7, and remember I said you can take negative 1 and negative 5 and try and plot it in to see if we get the same c value. But in this case, I substituted in 6 and 7, and I got the final answer of c being equal to negative 23 over 7. And remember, they asked you to determine the equation. So you have to say, therefore, y is just going to be equal to 12 over 7, which was our gradient, x minus, remember this one is a negative 23 over 7, it's going to be minus 23 over 7. And therefore that is our final equation for our function. It's a lot of fractions, and we can actually, if you want to make it look fancy in this case, we can actually just write it as y is just going to be equal to, then we're going to have it as the following. It's going to be, you know what, let's not do that. It's fine. Let's just leave it like that. It's going to look confusing. But yeah, there's our y equals to mx plus c. Once again, okay, what I was going to do, you can't do that, because remember, you need to have it in this form. I was just trying to be fancy, but it's okay. So there's our equation, and that is how we determine the equation of a linear function.